there are a few ways to solve a problem like this. I'm going to rip through the big picture logical version first, and maybe we'll talk about the other one for a second at the end. But we have 4 machines that can produce X units, whatever that means, in 6 days. Now, when we work together, we get stuff done faster. So if you imagine that we had one guy that could do a full job in 100 days. Well, if 2 guys work together, they will do the job in half as long, 50 days. And if 4 guys work together, they will do the job in 25 days. Because each of these guys working for 25 days means that we have one guy doing 25 days worth of man labor, and then we have another guy doing 25 days worth, and another guy and another guy. So the total amount of work that is done, since there are 4 guys working all 25 days together simultaneously, is the same 100 days worth of work. Now that's the same idea here. So 4 machines can do X units in 6 days. Well, that means one machine would take 4 times as long. And I want to start there. So one machine can do X units in 24 days. Now we're looking for 3X units. So that machine to do 3X units would take 3 times as long, because that's 3 times as much work. And 3 times 24 is 72. So one machine doing 3X jobs, or producing 3X units, would take 72 days, because it's going to take 3 times as long. Now we want to get it done in 4 days. We need to do 72 hours worth of work in 4 days. And that means we're going to need to divide this by the number of machines that we have to get to 4, which means if we multiply both sides by X there, we're going to get 72 equals 4X, and then X equals 72 over 4. And 72 divided by 4 is going to give us, 72 over 2 is going to give us 70 is 35, that's 36. And then divided by 2 again is going to give us 18. So that means X would equal 18. And the question is, how many of these machines working simultaneously and independently? So 18 is our answer. And that means that our answer is answer choice B. Now, if we wanted to do it from a more technical standpoint, we could solve it using the work rate formula that we've seen before. And basically that formula would say, if you have 4 machines that can produce X units in 6 days, just call X units one job. So instead of X units, call it 1 unit, and then we'll call this 3 jobs. So we would have 4 over the number of days that it takes one machine to do a job equals 1 job in 6 days. And if we cross multiply, we find out that A equals 24. Which is what we found out in this other situation up here as well. And once we have that information, we're trying to figure out how many machines working at 1 job every 24 hours would produce 3 jobs in 4 days. So 24 days on the bottom, rather, not hours. And if we do the cross multiplication here, we're also going to get X equals 18. And this is the more technical version. I like the big picture idea of just like deconstructing it. It's going to take one machine 4 times as long, and that means 24. And then to do 3X worth of work, it's going to take 3 times that. And then I need to divide by the number of machines and get to 4 days. And that is just like walk through it logically, and you'll get to the answer as well.